Hello, ladies and gentlemen. Today, we're going to do Experiment 19, Thermodynamics. Solid magnesium is one of the main components that is used in flares. Flares are used to light up the sky during nighttime activities. It is also used to aid in the signaling of one's location. The burning of magnesium ribbon demonstrates the combustion of magnesium, and a great deal of light energy is released from this reaction. Because this reaction is highly exothermic, it would be difficult to directly determine the amount of heat associated with this reaction. However, we can use an indirect method of measuring the heat that is produced. The thermal energy transferred in a balanced chemical reaction that is carried out at constant pressure is called the enthalpy of the reaction, or the heat of the reaction, and its symbol is delta H reaction, and its units are kilojoules per mole. Enthalpy is a state function, meaning that the enthalpy change of a reaction is independent of its path and depend only on the initial and final states of the reactants and product. This is called Hess's law. Hess's law states that the enthalpy change of a reaction is the same whether it occurs in one step or in many steps. According to Hess's law, we can combine the following reactions in a manner that will give us the desired reaction. For this reaction, we will find the delta H value for the reaction of magnesium solid plus 1/2 oxygen gas to give us solid magnesium oxide, using a series of chemical reactions. For this reaction, we will use Hess's law to determine the delta H value for the reaction of solid magnesium with 1/2 oxygen gas to give us solid magnesium oxide. We will do this by carrying out a series of chemical reactions and then experimentally determining the delta H values. However, due to hydrogen gas being explosively flammable, we will not conduct this reaction to experimentally determine the delta H value. You will use the Appendix C in the back of your lab manual or one of the appendices in the back of your textbook to theoretically calculate the delta H value for this reaction. Once you have the three delta H values, you can combine them using the rules for Hess's law and calculate the enthalpy change for the overall reaction. So now, let's move on and conduct our experiment. The first step in this experiment is to weigh and record the mass of the calorimeter. Please pause the video and record the mass of the calorimeter. Next, we will measure out 60 milliliters of a 1 molar hydrochloric acid solution and add it to the calorimeter. Next, we will record the initial temperature of the hydrochloric acid solution. Please pause the video and record the initial temperature of the solution. Next, we will weigh out approximately 0.6 grams of granulated magnesium and add it into the calorimeter. Please pause the video and record the mass of the magnesium. Once the magnesium has been added to the calorimeter, you will take temperature readings at 30-second intervals. You will record temperature and time measurements until all of the particles are dissolved. You will use this data to plot a temperature versus time graph similar to the one that's on page 167 in your laboratory manual. Occasionally, the calorimeter will be swirled as you take your measurements. Once the temperature has leveled off, we will weigh the calorimeter and get the mass of our solution. Periodically, we will check to see if all of the magnesium has dissolved. Now that the temperature has leveled off, this temperature is the final temperature of your solution. Please pause the video and record the final temperature of your solution. Now that the reaction is complete, we will take the mass of the calorimeter in our solution. Please pause the video and record the mass of the calorimeter and our final solution. For part 2 of the experiment, we will combine magnesium oxide and hydrochloric acid. Starting with the calorimeter, we will weigh the mass of the calorimeter that will be used in this portion of the experiment. Please pause the video and record the mass of the calorimeter. Again, we will measure out 60 milliliters of a 1 molar hydrochloric acid solution and add it to the calorimeter. And then we will measure the initial temperature of the hydrochloric acid. Please pause the video and record the initial temperature of the hydrochloric acid. Next, we will weigh out approximately 1 gram of magnesium oxide and add it to the calorimeter. Please pause the video and record the mass of the magnesium oxide. Once the magnesium oxide is added to the calorimeter, you will record the temperature and time in 30-second intervals until all of the solid is dissolved. Periodically, the calorimeter will be swirled as you take your temperature measurements. We will now check and see if all of the magnesium oxide has dissolved. Because there are still some particles of magnesium oxide present, we will give it another swirl and allow the reaction to continue until all of the magnesium oxide has dissolved. Once the temperature has leveled off, this temperature will be the final temperature of your solution. Please pause the video and record the final temperature of your solution. Now that the reaction is complete, we will get the mass of the calorimeter and our solution. Please pause the video and record the mass of the calorimeter and your solution. You now have all the data that you need to complete the calculations for this experiment.